Good morning all. So today's discussion we can move through moist heat methods of sterilization. So of all methods available for the sterilization, moist heat method, that is in the form of saturated steam under pressure, it is the most widely used and most dependable method. So actually coming to the moist heat method, that is steam sterilization, it is non-toxic, inexpensive, rapidly microbicidal and sporicidal, and also it rapidly penetrates the fabric. The moist heat sterilization using autoclave, it is commonly used for the sterilization of biohazardous trash, heat and moisture resistant materials such as aqueous preparation or culture media. And this method is also used for the sterilization of surgical dressings and medical devices. And here in the case of this moist heat method, the most common type of steam sterilizer which are used in the microbiology laboratory is gravity displacement type. Another type of autoclave is vacuum gravity assisted. So this autoclave and other methods that I will discuss later, which comes under moist heat method, and the mode of action is mainly the bacteria and viruses are made up of proteins, and this moist heat sterilization works by denaturing these proteins. So the denaturation is the main mode of action, and this denaturation is the process in which the structures of the proteins are disrupted and altered. And once the bacteria and viruses are denatured, they will be unable to cause any type of infection. Apart from this advantage, some sort of disadvantages are also present in moist heat sterilization. While we are using steam or water vapor in the moist heat sterilization, the objects will get wet and have the potential to rust. That is one disadvantage, and other points we will discuss later. Additionally, any time pressurized heat is used, there is a potential for people to burn themselves. That is also another disadvantage. And again, coming to this mode of action, same point, it destroys the microorganism by irreversible denaturation of the both enzymes and structural proteins of the organisms. And the temperature at which denaturation occurs, which may vary inversely with the amount of water present. And the sterilization in the saturated steam thus requires a precise control of time, temperature and pressure, that we have already studied in the last year about autoclave. It has a time period and also temperature and pressure. For example, 121 degrees Celsius for 15 lbs. And this pressure serves as a means to obtain the high temperatures necessary. So whenever the pressure increases, what happens? Temperature also increases, and it becomes necessary to quickly kill the microorganisms. The specific temperatures must be obtained to ensure the microbicidal activity, and the minimum sterilization time should be measured from the moment when all the materials to be sterilized have reached the required temperature throughout. The recommendation for the sterilization in an autoclave is 15 minutes at 121 degrees Celsius. That is in the case of autoclave. The temperature should be used to control and monitor the process, and the pressure is mainly used to obtain the required steam temperature. These are the another conditions in which different combination of time and temperature are given. In the case of the temperature in between 126 to 129, approximate pressure will be 250. Minimum sterilization time is 10 minutes. From this we can see that this whenever the temperature and also this whenever the pressure increases, this temperature also increases and the time will be required for the sterilization will be minimum. In certain cases, there is thermolabile substance. Sterilization may be carried out at temperatures below 121 degrees Celsius, provided that the chosen combination of time and temperature has been validated. Next is about monitoring of steam sterilization. Like other sterilization systems, the steam cycle, it is monitored by mechanical and biological indicators. In the hot air oven yesterday we have discussed about the different types of indicators, biological and chemical indicators. In the steam sterilizers usually are monitored using a printout or graphically by measuring the temperature, the time at the temperature and also the pressure of the steam sterilizer. In the case of these chemical indicators, they are affixed to the outside and they are incorporated into the pack to monitor the temperature or time and temperature. Autoclave indicates a tapes which are commercially available. So a tape is present, that is indicator tapes, and they change color which suggests what proper sterilization. So a tape, that is indicator tapes, are placed inside they are placed and also they are commercially available. Another type is temperature monitoring probes are also inserted into the representative containers with additional probes placed in the load at the potentially coolest and least accessible parts of the loaded chamber. The conditions should be within plus or minus 2 degrees Celsius and plus or minus 10 kilopascal of the required values. And each cycle should be recorded on time temperature chart or other suitable means. So a chart is provided with headings of time and temperature, and after each cycle the time and temperature is marked on that chart. From this we can evaluate whether the steam sterilization is accurately performed. This is the method. Next is the biological indicators. And this effectiveness of the steam sterilization, it can be monitored with the biological indicator using the envelope containing spores of Geobacillus stearothermophilus, and it is formerly called Bacillus stearothermophilus ATCC 7953. So now it is known as Geobacillus stearothermophilus. Example ATCC 795 Bacillus stearothermophilus, and the D value, that is 90% reduction in the microbial population, that is the D value. It is 1.5 to 2.5 minutes at 121 degrees Celsius using about 106 spores per indicator. This is based on a worst case scenario that an item may contain a population of 106 spores having same resistance as that of Bacillus stearothermophilus. And after the sterilization is over, the strip is removed and inoculated into the tryptone soya broth, and they are incubated at 56 degrees Celsius for 5 days. No growth of Geobacillus stearothermophilus indicates proper sterilization, and this is how the sterilization in biological indicators are used to monitor the efficiency of steam sterilization. So these are the commonly used biological indicators. That is geobacillus, spores of the bacteria and their D value. In the case of Geobacillus stereothermophilus, D value is 1.5 to 2.5. In Bacillus coagulans 0.3, Clostridium sporogenes 0.8 to 1.4, Bacillus atrophius 0.5. So these are the spores of the bacteria used in steam sterilization. The positive spore test results are a relatively rare event and can be attributed to the operator error, inadequate steam delivery, or equipment malfunction. Next is the advantage of steam sterilization. It is non-toxic to patient, staff, environment, and the cycle is easy to control and monitor, rapidly microbicidal, least affected by organic or inorganic soils among the sterilization process listed, then rapid cycle time, and also it penetrates the medical packing and device lumens. Next is the disadvantages of the steam sterilization. It is deleterious for heat sensitive instruments. So the microsurgical instruments are damaged by repeated exposure. And also another disadvantage, it may leave the instruments wet, causing them to rust, that we have discussed earlier, this point. And also there is a potential for causing burns. So these are the disadvantages. Otherwise, steam sterilization is quite good. And in the next session or next class, we can discuss the moist heat sterilization. We are using it in 3 forms. That is, at the temperature below 100 degrees Celsius, at the temperature at 100 degrees Celsius, and also at the temperature above 100 degrees Celsius. So these are the 3 types in which the moist heats are used, and that each of them we can discuss in the later sessions. Thank you all.